The next step will consist of extracting the training samples. To do that, we load the provided shapefile with the training samples in point format. We intersect this layer with the segmentation one, so that the actual value contained in the training samples and the computed metrics from Sentinel-2, Worldview 2, and LiDAR will be kept. And we save it directly as CSV file. Now we have to check if the new CSV file created contains null values and replace them. With the question mark. And we save it. Now we can open Weka. We load the CSV file containing the training samples. And we remove the ID fields that are not significant for the classification model, such as the ID, ID_2, and VN. Then we select the attributes. We select the wrapper subset eval as the attribute evaluator and the decision tree J48 as a classifier. The gradient stepwise as the search method. And we select the samples attribute as a class. Once it's finished, it indicates the attributes we must keep. Therefore, we go back to the Preprocess tab, we select all the attributes, and we uncheck those we want to keep, plus the dependent variable, and we remove them. Next, we will change the order of the attribute to keep the dependent variable in the last position. To do that, we select the reorder filter in the unsupervised attribute folders. Rewrite the new order. We apply the filter and we save it as an ARF file. Then we can train the model using random forest. Cross-validation with 10 folds and indicating the dependent variable. Once the model has been trained and evaluated, we save it with a right click. The next step consists of opening the CSV file containing the metrics for all the objects. In other words, the information to which we will apply the trained model to classify the whole study area. To do that, we load the corresponding CSV file and we only keep the same attributes we kept for the training set. So we only kept the same attributes that for the training dataset. Then we save it as an ARF file. Now we open the ARF file with the notepad to edit the attribute corresponding to the class or dependent variable. In this case, the class is unknown, since we want to classify all these objects, but we must indicate among which values. So we open the training dataset and we copy the possible values of the samples attribute and we paste it and we save it. Now we will apply the train model to the whole study area. To do that, we open the Windows command prompt and we type the following command line. In here we are indicating the file we want to execute, the classifier model, the input file with the objects to classify, the train model, and the output text file, and we launch it. As a result, we obtain a text file so that if we open it, we can observe the instance number, the actual class, which is unknown, the predicted class, and the error prediction. So the next step consists of opening this file in Excel to remove the unwanted information. We import the text file, we keep only the necessary information such as the ID and the predicted class. However, the predictor information must be filtered to keep only the string after the colon. To do that, we can use Excel code. As this column depends on the previous one, we copy it and we paste its values. Now we can remove the previous column, edit the names. However, actually the number of instances assigned by Weka does not correspond to the correct ID of each polygon created previously to join the multispectral and LiDAR matrix. In this case, it's an incremental value from 1 to the number of instances. Therefore, we must create a new ID to join the predicted classes with the geometry informations. Since the order for the predicted information is the same than the order of the polygons in the segmentation shapefile, we can create an incremental ID from 0. And we save it in CSV format. Then this file can be opened in QGIS. We also modify the ID for the segmentation shapefile from 0 with an increment of 1. Then we can join both datasets. We do right-click on the segmentation objects and properties, and we create a new union with the prediction file. Finally, we can change the symbology of the predicted classes to visualize the result of applying the trained model to the whole study area. To sum up, in this practical work, we have trained, evaluated, and applied a model to classify the field models in a forest area at the object level using Sentinel-2, Worldview 2, and LiDAR data. Thank you for your attention.